Hey y'all, so this is the beginning of savings, the savings videos, and I'm only going to record simple interest for this one. So let's get through that and then I'll do a couple more. When you are rounding money, American money has to always be rounded two decimal places to the right, two places to the right of the decimal. And that is where the hundredths place is. Okay. It's basically you're rounding it to the penny, to the nearest cent. So if you think about, I'll grab a pen, if you think about money, you will never write that. You wouldn't. You would always have to write zero over here to represent the ones place. All right, the pennies basically. So the dollar sign goes on the left. I've seen many people put it on the right. It goes on the left. $2.70. If you have 2.7, I don't know what that is. You should always have something in the hundredths place if you have change. Okay. So here's a definition of APR, which stands for annual percentage rate. It is the total interest paid in a year. The cool thing about this is we've already covered what R is. And it is truly just our representation of R in decimal form. That is R is our percentage that we've already used in our exponential functions. So this is nothing new for you. It's still going to be the same. It's a percent. You're going to have to change it to a decimal. Okay. Also, from our exponential functions, I have P as our starting amount or initial value. It's also going to be considered principal, not of a school, but of the amount of money that you're investing in an account. All right. And then let's just talk about the next two. A is the ending balance after T years. So before we had F of X was the ending balance. Now we just have A. Okay. And then T is the time and the number of years the money is left in the account or it's owed. All right. So let's talk about that is the simple interest formula. Okay. Money is deposited in the account only once. There's only going to be one of these on your exam, the simple interest formula. And all you need to know to make sure you're using the right formula is the word simple. So when you see the word simple in a problem, you already know this is the formula you're going to use. Okay. Simple interest grows at the same value every year. And I'll show you an example of that here in just a moment. It does not compound. When you're watching those videos that go in MyOpenMath, you're going to find that they say, oh, to find the interest is PRT. Yeah, but that's only for simple interest, and you only have one of them on your exam. Don't waste your time. Do not even write this down. I want you to get comfortable with learning how to calculate the interest, how it's accrued. The interest is equal to the ending balance minus the beginning balance. Okay, that's it. The reason I want you to learn this one or to have this one on your note card is because it's going to be the same one as another one here in just a moment. Okay, so you'll be able to use it for a couple different options. The only other thing I wanted to say about this, the money is put in once and then that's it. But to find out, to make sure you're using the right formula, look for the word simple. I will be providing this formula on the exam. Okay. I will not be providing this. Make sure this is in your note card for your simple interest. Okay. So do whatever you need to do to make sure you don't miss that. And here's an example. Janelle invests $18,000 at 8% simple interest for 41 years. Okay. That right there tells me I'm using that guy right there. Period. Janelle invests 18,000. So she's investing 18,000. That's her P. So we've got A, P, R, and T. P is 18,000. I didn't want to use red. The rate is the 8%, but remember to turn a percent to a decimal, you have to divide by 100. So 8 divided by 100 is 0.08. And then time is 41 years. So we're looking for the ending balance. How much is in the account at the end of the 41-year period? So this is going to be A is equal to 18,000, following the formula here. 1 plus the rate is 0.08 times 41. Use it whatever symbol you want, but this is multiplication. Okay. I'm also going to show you how to throw this whole thing in your calculator at once. Boom, I'm done. Literally, you can type it in exactly as it is right here. Okay. 18,000 parenthesis 1 plus 0.08 times 41 close parenthesis equal. If you didn't get that, look to see if you're using a TI-30XA. If you are, then you might have to put a right in between the 18,000 and the parenthesis, you might have to hit your multiplication. The TI-30XA requires that. Otherwise, if you're using your phone, if you're using a TI-30X2S, a graphing calculator, they will all be able to put in exactly as they are. But if you have a TI-30XA, for all of these, you're going to have to put a multiplication symbol right in between the P and the parenthesis. Okay. So my answer is, this is word problems. So we have to answer with words. It says, how much is in the account in the end of the 41-year period? I'm going to say $77,040 is in the account. Now, there's something missing. You must provide correct units. Okay, be very careful there. Do not forget your dollar signs. Let's go to the next part. For every stinking one of these, I'm going to ask you how much interest accrued. That means how much interest built up over that time period. How much interest did that $18,000 earn Janelle over that 41-year period? So to find that, it's just the ending balance minus the beginning balance. Minus the beginning. That makes sense. How much do you have in the end minus what you had at the beginning? That's the interest, because you're not putting any other money in. So notice I've already got 7,704 in. I just need to go subtract the $18,000 investment. And don't forget your dollar sign, $59,040 in simple in interest accrued. In interest accrued. And you could say over the 41 years. Usually time makes that a nice add-on, or you could just say the amount in interest accrued. You give me a sentence. All right, let's go to the next one. Carlos invests $15,000. That's his P, that's his initial investment at a 2% simple interest. Because it has simple, all I need to know is that, and I'm using A equals P1 plus RT, and I equals A minus P. Okay. He's investing 15,000. 1, 2, 3. And his rate is 2 divided by 100, which is 0.02 times 29 years. Put it in directly like this, unless you're an XA. 15,000. You can watch me do it. 15,000 parenthesis 1 plus 0.02 times 29 close equals $23,700. Don't forget your dollar sign. $23,700 in interest accrued. I'm sorry, goodness gracious, is in the account. Sorry, I was looking at the wrong line. Now, again, I just said is in the account up here. I could also say is in the account after 29 years. Are either one righter or wronger? Well, the 29 years is more information, but just give me a sentence. The most important thing is rounding, units, and sentence. Okay. How you're doing it. If it makes sense, that's fantastic. Interest accrued. I equals the ending amount, 23,700, minus the beginning amount, 15,000. And you just subtract those two. I already got the 23,700 in. I just need to subtract 15,000. And $8,700 is the interest accrued. In interest accrued. As I'm going through this, if you missed class and you're watching this, or even if you didn't, the best advice I can give you for this is if write any questions you have over to the side or on a separate sheet of paper or in the margins somewhere so that you can ask me. Come in and chat with me and let's find out what issues you're having. Okay. All right. Christina invests $13,000 at 7% simple interest for 32 years. How much is in the account at the end? I want you to do this one. I want you to pause the video and I would like for you to do this problem here. Okay. And then come back and see how you did. I'll give you the formula. A is equal to P1 plus RT, and the interest is I equals A minus P, the ending amount minus the beginning amount. Pause the video, go do that, and come back and see how you did. All right. Invested 13,000. 7% simple interest. 7 divided by 100 is 0.07 times time is 32 years. Put that in directly in the calculator. 13,000 parenthesis 1 plus 0.07 times 32 close parenthesis equals 42,120. $42,120 was in the account. At the end of the 32-year period. At the end of the 32-year period. All right. Interest. Interest is just the ending amount, 42,120, minus the beginning amount, 13,000. So you've already got 42,120 in your calculator. Just subtract that 13,000 and you're done. Interest that accrued is 29,120. In interest accrued. How much would you need to deposit in an account now? Oh, this is different. In order to have $3,000 in the account in 5 years. Assume the account earns 2% simple interest. Well, this right here tells me I'm using my simple interest formula, but I think this one's a little different. It says, how much do you need to deposit? So we're looking for our P. So our A is 3,000. So we want to have 3,000 at the end. We need to know how much to invest at simple interest at 2% times 5 years. Now there's a few different ways you can math this. You could just go and 3,000 divided by everything over here, or I'm going to go ahead and simplify what's in this parenthesis first. So 1 plus 0.02 times 5 is 1.1. Now I just need to solve for P. So I have to divide both sides of the equal sign by 1.1. And I get that the amount of investment is 3,000 divided by 1.1 is 27.27. So all I need to say is, it says, how much would you need to deposit? You need to deposit, or I need to deposit, pick a person to deposit Do not forget your dollar sign, $22,727.27. Okay. Interest accrued. The ending amount is 3,000 minus the beginning amount, which is the amount invested, $22,727.27. Please do not just leave the number in your calculator and subtract. It will be wrong. You have to round to write your sentence. You have to round. You do not round ever, ever, ever until you get to write your sentence. That's when you round. Okay. So then you're going to take that rounded number to calculate the interest. That's what the banks are going to do. Okay. So I need to clear my calculator. 3,000 minus $2,727.27. So $272.73. $272.73 in interest accrued. Okay. So that one was solving for P. I'm sure the next one is as well. Let's see here. How much would you need to deposit again in an account now in order to have $2,000 in the account in 15 years? Assume the account earns 6% simple interest. So pause the video, go do this one, and then come back and see how you did. Okay, it's just like the previous one. I'll put it down here so you can see it. All right. So it says, how much would you need to deposit? So they're telling us we want $2,000 in the account. We need to find out how much we need to invest. 1 plus 0.06, because 6 divided by 100 is 0.06, times our time, which is 15 years. All right, I'm just going to simplify the right. 1 plus 0.06 times 15, and I got 1.9. I'm going to divide both sides by 1.9 to reduce it. 2,000 divided by 1.9. Okay, so I got $1,052 and 63 cents. Don't forget your dollar sign. The question was, how much do you need to deposit? You need to deposit. And I already wrote the number. There you go. Let's find the interest accrued. The interest accrued is just the ending amount, $2,000, minus $1,052.63. I have to clear my calculator anyways. 2,000 minus $1,052.63 is $947.37. Don't forget your dollar sign in interest accrued. Okay. All right. This is the last page for this lecture, and then I'll move on to a different video. You invest $9,600 in a savings account. Okay, so you're investing it. That's your P. It pays 3.6% simple interest. I'm using my simple interest formula. And the 3.6 divided by 100 is 0.036. So I went ahead and did that. How long will it take for the investment to double in value? So you have one like this on your homework. So what does that mean to double in value? That means that the $9,600 is going to double. Well, what does that look like? $9,600 times 2. It doubled. So we want $19,200 in the end and $9,600 invested initially. 1 plus the rate is 0.036 times time, which is what we're looking for. How many years will this take to double? Okay. So we need to isolate T. We can't just go in here and just start doing stuff. All right. We need to start getting everything away from the right side of where the T is. So I'm going to start by dividing both sides by 9,600. When you do that, this is gone and we're left with 2. because 19,200 of 9,600 times 2 is 19,200. So divided by 2. Sorry, 19,200 divided by 9,600 is 2. And then we're left with 1 plus 0.036 times t. The next thing we have to get rid of is the 1. We can't get rid of anything over here yet because we've got to get rid of this 1 before we can divide. So I need to subtract 1 from both sides of the equal sign. And I get 1 is equal to 0.036 t. Last step, divide both sides of the equal sign by 0.036. We're dividing because the 0.036 is attached by multiplication, so we have to divide to get rid of it. 1 divided by 0.036 is 27.77. Now, this is years. Let's talk. You can't say 27 because that wouldn't be enough. You could say 28, you'd just be over a little bit. So I'm fine with if you answer 28 years, or if you say 27.8, because I know we discussed in class using the tenths place for our answers for decimals. So you could say 27.8 years. Either one of those would be acceptable for me, okay? But I do want a sentence. So how long will it take for the investment to double in value? It will take, and then you choose which one you're going to give me as an answer. I would accept either, unless I tell you something different. How much interest accrued? We didn't, okay, so all we have to do here is the ending amount, which is 19,200, minus the initial amount of 9,600. And when you subtract them, you're going to get 9,600. So don't forget your dollar sign, $9,600 in interest accrued. All right. Go to this next one. It says Janelle wants to invest $500 in a savings account that pays 4.3% interest. How long? Oh, we're doing the same type again. How long will it take for this investment to triple in value? So that's going to be 500 times 3. So we want $1,500 at the end. 500 initially invested. The interest rate is 0.04, is 4.3% simple interest. Remember on the exam, I'm not going to tell you that it says it's not, well, this one will say simple, okay? It will say simple. So you'll already know because it says simple interest. And we're looking for the time. So I went ahead and set this one up for you. Pause the video and finish this. Make sure your algebra is good. So pause the video, go do it, come back and see how you did. And then the next one, I'm going to have you do the whole thing because it's going to be just like the one previous. All right, so we're going to divide both sides by 500. 3 equals, this reduces, 1 plus 0.043 times t, subtract 1 from both sides. And I get 2 equals 0.043 t. I'm going to come up here, just so that I can show you my next step. This is 8, or it was a 2. That's a 2. All right, 2 is equal to 0.043 t. I'm going to divide both sides by 0.043. This reduces, and I'm left with the time. 2 divided by 0.043 is 46.5 years. It will take 46.5 years to triple. Okay. Oh, and interest. Got to do interest. Interest is the ending amount minus the beginning amount. So $1,000 in interest accrued. Pause the video and do the next one. It says Brian invests $1,200 in a savings account that pays 5.1% simple interest. How long will it take for this investment to double in value? Pause the video and do this one yourself and then come back and see how you did. All right. So we want the $1,200 investment, which is our P, to double in value. So that's 1,200 times 2. 2,400. That is the amount we want to have at the end. 1,200 is the initial investment. I didn't need a dollar sign. 1 plus. Ooh, it's 5.1%. So 5.1 divided by 100 is 0.051 times, and we're looking for the T. Start by dividing both sides by 1,200. 2 is equal to 1 plus 0.051 times T. Subtract 1 from both sides. 1 is equal to 0.051 times T. Now, I'm going to come up here. 1 is equal to 0.051 times T. Divide both sides by 0.051. And I get T is equal to 19.6. So it will take 19.6 years to double in value. Actually, it should be 0.7, shouldn't it? Because it was actually more than 0.6. Say 20. I'm perfectly fine with that, y'all. To double in value. Double in value. Per year, right? And then how much interest accrued? That is just your ending amount, 2,400, minus your initial investment, 1,200, which is equal to 1,200. So $1,200 in interest accrued. Let me know what questions you have. I hope you took notes on this as far as any questions you had. Make sure that you understand when you're going to use the simple interest formula. Okay. And make sure that you have in your notes that you're going to write I is equal to A minus P, or whatever you want to write to find the interest for the simple interest formula. That's the most important thing right now. Okay. I'll see you in the next video where I start compound interest.